Hello friends, welcome back to CSharp.net online training video series. Today we are going to discuss anonymous method real-time example. Before proceeding to this video, I recommended you please watch our previous video where we discuss anonymous method, where we discuss what is anonymous method, how to create anonymous method, how to use anonymous method in C#, right? So today I'm going to give you one real-time example of how to use anonymous method. So first of all, what is an anonymous method? As the name suggests, an anonymous method is a method without having a name. That is, it is an unnamed code block. So in C Sharp, we can create a code block by using a name or without using a name. If we are providing a name to our code block, then we can say it's a method. And if we are not providing any name to our code block, then we can say it is an anonymous method. And in our previous video, we have already discussed if we want to create a code block without name or if you want to create any anonymous method, then we need to use the delegate keyword. And again, once you create the anonymous method, then we can assign that anonymous method to a variable of the delegate type. That what we have already discussed. So in simple word, we can say that an anonymous method is a method without having a name. Now let us proceed and try to understand how a method can exist in C# without a name with one real-time example. So first of all, let us create a class file with the name employee.cs and let me copy paste this code, right? So you can see I have created one class file with the name employee.cs, right? And inside this employee.cs class file, I'm creating one class with the name employee, and this class having four auto implemented properties, and all these properties are public properties: ID, name, gender, and salary, right? So this is a simple class. Now what I want is we want to use one of the generic one of the generic delegates. So in our generic delegates video we have discussed, we are having three different kinds of generic delegates. One is func, another one is action, and another one is predicate generic delegate, right? And we have discussed that we need to use predicate generic delegate whenever the delegate takes one input parameter, that is maximum one input parameter of any type, right? Any type in the sense it might be a built-in data type like integer, float, character, any user-defined data type like string, or any user-defined data type like employee, product, anything, or built-in built-in reference type. You can also pass like string and object. Means it is going to take only one input parameter, and if the method is going to return you some boolean data, right? Then in that case, instead of creating your custom delegate, right, you can use the generic predicate delegate. Now, if you go to the definition of this generic predicate delegate, then you will see that, okay, let me write the predicate and let me select and let me go to the definition, and you can see this delegate except one parameter of type t in the sense it can be any type, and this method is going to return one boolean data, right? So you can see, as you can see in the above image, the predicate generic delegate takes one input parameter of type t and returns a boolean value. Here I'm mentioning t. What it means? It means it can accept any type of a data, but the return type, it is a fixed value. It is fixed. That is, the return type is going to be boolean. So now what we need to do? If I want to use this predicate generic delegate, then I need to create one method whose signature should match with this predicate of t signature. So for that, what I'm going to do, I'm creating one method. You can see this is one method, each employee exists. So in step two, what I'm doing, I'm creating one method. Let me remove this one. So see, the step one is creating a class file. The step two is create one method whose signature should match with the predicate of employee, right? That means predicate of employee means generic predicate employee taking one employee type parameter. So in this case, each employee exists, it's a method, and this method taking one parameter of employee type, and this method is returning a boolean value. That means this method signature, right, is same as the predicate generic delegate signature, right? So the logic is very simple. What is logic now? We have to pass one employee object to this method, and if you look at the employee object, this employee object having some parameters: ID, name, gender, and salary. That means ID parameter is one of the parameter, and we are checking if that ID parameter equals to 103, then I need to return that the employee is exists. So basically in real time scenario, what you need to do, In real-time scenario, you need to take this ID value, you need to go to the database, and in the database, you need to check whether that employee is exist or not. If that employee is exist, then you need to return that employee is exist. If that employee is not exist in the database, then you need to return that the employee is not exist, and in that sense, you need to return. So in this case, I'm writing the simple logic. If the ID is 103, then it is going to return true, else it is going to return false. And most importantly, this method signature is same as our predicate generic delegate. Right? Now, in step 3, we are going to create an instance of the predicate generic delegate. While we are creating the instance, we need to pass the each employee exist method as a parameter to the constructor. Right? So you can see this is my each employee exist method. Now what I need to do, I need to create an instance of a predicate employee, and to the constructor of this generic predicate delegate, I need to pass this method as a parameter. This is nothing but our step 3. So you can see this is my predicate. So I'm creating an instance of my predicate delegate, and while creating the instance, I'm passing this each employee exist method as a parameter. I can pass this parameter, and this is acceptable because the syntax is like this. This predicate accept one parameter of employee type, and this predicate, as it's a generic predicate, the return type is going to be boolean. So in this case, this method taking one parameter of employee type and the return type is boolean. So you can pass that as a parameter to the generic predicate delegate. This is our step 3. Now in step 3, what we need to do is we need to create a collection of employee type. So basically, I'm creating here list of employees, and this is a very straightforward code. You can see I'm creating a list of employees, and this employees having few data like 5 employees information I'm storing into this collection, right? So this is nothing but our step 4. You can see this is my step 4. I'm creating list of employees, and to this list of employees, I'm adding employee object, right? So this is a collection. Now, once you create the collection, then what you need to do, we need to pass the delegate instance, that is employee predicate, to the find method of the list collection class, right? And you can see you have the list of employees. We have the employee predicate. Then what you need to do, you need to pass the employee predicate as a parameter to this find method. So what this find method is going to do, now it is going to check all the employees that are present inside this employees delegate and trying to figure out which employee ID is matched, right? So that means what exactly happening behind the scene. Now for each employees, right, the delegate is going to invoke this method. For first employee, what is the ID? The ID is 1001, right? It will call this employee method by passing employee object whose ID is 1001. So in this case, it is returning false. Then it will going to the second employee, right? The second employee ID is 102. So in that case, again, the employee predicate is going to invoke. So if you are getting confused how it is going to invoke, you can know, we know already that we can invoke a delegate like a method, or you can also use the invoke method, right? So in this case, you can see the second about the second employee object, this method is also going to invoke, and in this case, it is going to return me false. And when it invoke for the third employee object, right, in that case, right, this method is going to return true. And if it is returned true, then it will not proceed further. And what this find method is going to do is it will return that employee object which condition is matched. In this case, the employee object 3, the third employee object whose ID is 103, that matched. So that matched employee data is going to be written, and that is going to be stored inside this variable. Right now, if you run the application, then you will see that 103 is going to be displayed, or employee 103 information is going to be displayed on the console. So in this case, what we are doing, we are just passing that employee, we are just using the employee predicate and invoke that employee predicate internally going to invoke this method. So this is what we have discussed so far, right? So what we have discussed so far, now we create a method whose signature match with the predicate generic delegate. This is the method. This signature is matched with this predicate generic delegate. Okay, then we create an instance of a predicate generic delegate. You can see then we have creating an instance of this generic predicate delegate, and to this instance, while creating to the constructor of this delegate, we are passing the method, right? Then we passed that predicate generic delegate instance as an argument to the find method of the list collection class, right? So, and you can see then this instance what we created, we passed that as a parameter to this find method. And when we invoke that instance, actually this internally it is going to be like a loop for each employee data, right? For each element of the collection, it is going to invoke this predicate, which is internally going to invoke this employee is employee exist method. Now, so instead of doing this, can we use an anonymous method instead of a named block? See, in this case, what we are passing. In this case, we are creating one named block. So we are creating an instance of the delegate, right? First of all, we are declaring one delegate. We are creating one method, and we are passing that method as a parameter. That means three things we are going to do. We are doing, right? Instead of doing these three steps, we can pass an anonymous method as an argument to the find method, right? Simply what you can do this, simply what you can do is just copy this thing, right? We know how to create a delegate. Okay, you just tell me how to create a delegate. Now we can create a delegate by using the delegate keyword, and here we simply need to write this thing, right? This is our anonymous method, and this anonymous method is created by using the delegate keyword, right? Now we can simply remove these steps. This is not required, right? Again, this is also not required, right? So using anonymous method, we can simply overcome those steps, right? And now is for each employee data, right? This anonymous method is going to be invoked internally. And once it invoked, the logic what you have written that is going to be checked. For the employee whose ID is 103, for that employee, this method is going to return me true. And for if it return true, then that employee information is going to store in this variable. Now, if you run the application, then you will also get the same output as the previous example. Let me run the application. Yes, you can see the employee whose ID is 3103 going to be displayed on the console. So this is how you can work with anonymous method in C#, right? So what is this find method? Now in the above example, find method of the generic list collection class except a delegate to be passed as an argument. Now, if you go to the find method, right? If you go to the definition of find method, then you will see that this is not, this is accepting a predicate, right? Predicate of T. That means it is nothing but one delegate, right? So if you go to the definition, then you will see that it's a delegate and the signature is like this. So that is going to take one employee object as a parameter and that is going to return one Boolean value, right? So in this case, this delegate, this anonymous method is taking one input parameter of employee type and it is going to return me some Boolean data, right? Now what I can do, so if you try to return something other than Boolean, then you will see that this method is going to give me some kind of error because this find method accept one delegate which is going to return the data as a Boolean. In this case, we are not returning Boolean, we are trying to return integer. This is not acceptable because the predicate that this method accept, that predicate should be going to return, right? That predicate should be going to return some Boolean data. So in this case, if you write true, then it is acceptable, right? Instead of employee object, can I pass string? No, you cannot pass string. So if you pass string, then also it is going to give you one error. Why? Now, because this find method accept one delegate who is going to take the employee as an input parameter. But here you are passing string as a parameter, not acceptable because it is going to strictly check the type. Input type should be employee, output, the return value should be going to be Boolean, right? So why? Because this is the expecting one Boolean type, now predicate EMP, predicate of T, and T here is nothing but your employee. So you can see when I'm taking mouse over to this find method, you can see this find method except predicate of employee. And if the input is not employee and if it is not returning some Boolean value, then it is going to give you some kind of compilation error, right? So that's it for today. In the next video, I'm going to discuss one of the important concept in C#.NET, that is lambda expression. Thank you for watching this video.